Hi, Ilse.
Hello, Ivan. Good to see you.
So, yeah, I'm supposed to be now the tech support.
Yes, and
Okay.
you're all set to go because there's lots of questions that have been already partly discussed in the Mattermost channel for this session. But I see several ones which are worth mentioning in the plenary session, so other people are aware of this. It's a bit difficult to follow the threading in the Mattermost discussions.
Actually, I need the browser because I'm using the browser version. So now I have to take a look into the question and answer, the chat, and the Mattermost. Yeah.
Yes, there's not a lot of questions been asked in the Q&A. We don't have Q&A actually for this one. I forgot about that. The Q&A is only for the webinars. So it's the chat, and there was only one issue raised there, but Mark Kattenis answered this. This is a specific issue about VLBI data. That requires a little bit more investigation to answer, but there's quite a lot of discussion in the Mattermost, so that would be the one to focus.
Okay, so Mattermost is in the data prop 2.
It's channel B.
It's channel B.
B for Beef Bernard. So
yeah.
Everyone who is still working on their data, it's exactly on the hour, noon UT. So we're starting to move into the question session, and Ivan will be looking for issues that we can discuss that have been addressed partly or in full in the Mattermost chat, but are worth mentioning here as a remark for the plenary session, maybe have some further discussion on them.
Okay.
So if you're all set, go Ivan.
So in the chat, I just joined. Sorry for joining so late, Ilse. I just joined.
Getting a bit worried, but
okay. Yeah, so I don't see anything in the chat actually. I think that this is one of the problems.
Do you not see the channel, or do you not see?
No, the chat. The Zoom chat. It's
that's
empty.
Because you were probably because you joined after the question was asked. So there was a question about the VLBA data set, but nothing after that. So we can focus on the Mattermost channel, where there's a lot of discussion there.
Okay, so it's actually yes. So we start. It's at 11:22. So Oleg mentions that there is a problem with append thesis.py. Okay, for continuum pass it worked fine. I have to take care of the spectral line pass. Okay, so it's two different correlation passes of the same scans. By the way, also, so we mentioned the questions or copy them into.
There's two options, so you can read the questions, but in the plenary session, you can also ask the person who asked the question to repeat it here and see what the answer was. So you're at.
Okay, but there are no. So in the Mattermost, I can't see if there is an answer to that question. It's not ordered by threads.
Yeah, the threading is a bit tricky. If you click on the question, you should see a small. I'm not sure how that works in the browser version, but in my desktop client, if I click on the question or I hover over it, I get a little arrow that has a number behind it.
Reply. Okay.
Yeah, and then I scroll back to the top, and I see indeed the question from Mateusz.
Okay. So yeah, so there has been a problem in the import of the system temperatures. Yeah, in the spectral line experiment. So there is a correlator pass in the continuum, another correlator pass on the spectral line, and it seems that the append thesis didn't work. So then there is an answer from jive.mark. So it's who is Mark Kattenis, yeah. Okay, and the problem seems to be the SPW. Well, a possible solution would be the use of SPW map parameter. Okay, since the system temperatures would be the same. Okay, so because you are correlating the same photons basically, and changing the spectral configuration. So one could use the system temperatures used to calibrate the continuum pass to calibrate also the spectral line pass. And for that, the use of SPW map, which basically broadcasts the solution to different spectral windows, would be a natural solution for that.
Could you,
and actually, Oleg says, oh, okay.
Sorry to interrupt, but could you mention which question you are looking at? Because I see.
Sorry. Yes, I'm looking at question from Oleg at 11:22 a.m. who had a problem when importing the system temperature table. Yeah.
Okay, I see. Yes, I know that Mark was preparing some slides for this as well. So maybe if Mark is present, that would be a good time to. This might be a good time to discuss this in a little bit more detail.
Yes, I'm here.
Yep. Are you good to go for this discussion?
Yeah, I could say something. So I have actually looked at the problem now, and the funny thing with most line passes is that they only have one spectral window or one IF in ApeSpeak, and the script doesn't handle that properly because it's the ever returning. If there's only one, it's scalar. If there's more, it's an array, and you need to do the right thing in Python to handle those. The solution I suggested, though, was indeed what Ivan was saying. The amplitude calibration for that particular spectral window in the line pass should not be different from what it is in the continuum pass. And a way to handle that is using the SPW map feature that Des already showed. And I've prepared 2 slides, and I'm trying to show those now. Let me pick the right window. Why doesn't it show me the right window? Yes. So there we go.
Yep.
Hopefully you see something now.
Yes, we do.
Well, I probably can leave it like this. We've already seen the SPW map parameter. And basically what this allows you is to map spectral windows from a calibration table to spectral windows to the measurement set. Now, if you create a calibration table from a measurement set, it typically you get a calibration solution for each spectral window. So, so the calibration table has exactly the same spectral windows as the measurement set. Des already showed an example where that isn't the case. If you combine all spectral windows, then you get only one solution for all spectral windows, and the calibration table will have only a single spectral window in it. But the usual case is that you have just as many in the calibration table as in the measurement set, and you map them 1-to-1, so you don't need to do anything special. That's the default. But if you want to do something special, you can basically say, okay, I want to map spectral window 5 in the solution in the calibration table to spectral window 2 in my measurement set when I apply calibration, or when I do on the fly calibration because I solve for another effect. So this spectral window map parameter is basically a list of lists, where the inner list has an element for each spectral window in the measurement set. And the number in that list refers to the spectral window number in the calibration table, and the position in the list refers to the spectral window in the measurement set. And then there's an outer list because you have a spectral window map list for every calibration table that you try to apply. Now, this is a little bit difficult to understand. It's much best to look actually at an example. And a typical example to use this functionality is a spectral line experiment. So if you have a continuum measurement set with, say, 8 spectral windows, so most of your calibration tables, the amplitude calibration tables, will have calibration tables that correspond to these 8 spectral windows. And you have a line measurement set with only one of those spectral windows, but at much higher spectral resolution. And you want to apply, and say you fully calibrated your continuum data set and want to transfer that calibration now to the line set. You can do that in an apply cal, for example, by specifying the measurement set as your line measurement set, but using the calibration tables from the continuum data set. So here's the, presumably the gain curve calibration, the thesis, single band delay, and multi-band delay. Now, assume that the spectral window in the line pass is actually spectral window 5 in the continuum pass. You can now create a spectral window map parameter where we use spectral window 5 from the gain curve calibration, spectral window 5 from the thesis calibration, spectral window 5 from the single band delay, and the multi-band delay is special because we combined the spectral windows there. So there's only one multi-band delay solution. So there we have to pick spectral window 0. And if you now run this apply cal command, it should do the amplitude calibration and the fringe, and apply the fringe fit solutions in one go. And you could then further look at that data, image it, or whatever. In principle, this works. We have found some issues with if you try to do it the other way around, which is also possible, where you calibrate fringe fit, for example, a line measurement set, and then try to apply that that solution to the continuum measurement set. This is something that that people doing astrometry with masers sometimes do. There's a name for it that I forgot, something like reverse phase referencing, where you actually use your target to calibrate the phase calibrator, which in this case you want to, in that case, if it's close and weak, but you know the exact position of the phase calibrator, but don't know the position of your maser spots, that's a way to do the astrometry. It's probably people on the workshop that can explain that better than I do. So my suggestion to Oleg was that that he could, instead of using the NTAP information for the spectral line pass, simply transfer the amplitude calibration from the continuum pass to the line pass. But I'm now looking at the script and trying to fix it such that it will work for the line pass as well.
Thanks, Mark. I think this is very helpful. This spectral window mapping in CASA can be very confusing, especially if you're new to this. So I hope with this explanation that people will find their way around this. I'm handing back to Ivan, who has disappeared. Oh, you're here. Any other questions that are interesting?
So there have been several questions. Well, a good fraction of them regarding the software issues. Okay, so PlotMS had issues basically with the interface. Okay, So Mustafa Yildiz at 11:43 was asking about problems with the Jupyter notebook example, okay, with the first gen count command, which was giving an error. And there has been a reply for that. I don't know exactly how, whether this was finally fixed or the problem is still
okay.
remaining.
Yes, I missed that one. I'm not sure what exactly triggers the error. If this is a CASA related issue, but it looks more like a Jupyter notebook problem.
Mm-hmm.
And in that case, I would refer him to the technical support for that, where we have Art occasionally standing by for questions like this. The server has close to connection triggers, I think, is a Docker or notebook issue.
Mm-hmm. So it would be outside from CASA.
Yes, there is a channel that has number 0 technical Jupyter notebook questions. And if he posts it there, I'll tag Art to ask if he can look into this, if this is indeed a notebook issue or something else going wrong. It's not something I have seen before myself in the notebooks.
Okay, so that then still remains to be answered, and
Yep.
We are on it. Okay, so there are, as I said, there are a few complaints about plotms doing nasty things. So spawning new plotms windows every few seconds, as Paul Boven in Jai was saying at 11:55. Okay, so Paul Bowen was killing old CASA and starting again, so which is always a good idea. I actually quit CASA quite often and re-enter again every time something strange happens. So it's a very good idea to reset everything.
It's interesting to note here that when you launch CASA, you get a message that a tracker is launched to report to NREO if something really crashes. So people can switch this on or off in their CASA infrastructure, but I would suggest to keep it on because it's really helpful to the CASA developers to see which tasks tend to crash. The unfortunate issue there is that it only reports crashes which actually do a core dump or completely kill the CASA environment. So things like this will not be registered. So if you run into them more frequently, I'd recommend you to get in touch with the CASA people at NREO and tell them about this because problems like this seem to be under illuminated.
Okay, so there was a question by A. Coliout at 12:12 regarding the extraction of gain curve information for VLBI antennas. I think this is the one that was in the chat, right? Ilse, so from
sorry,
frequency
I'm trying to find the question.
At 12 p.m.
Yep, I see it.
Out.
Is there a way to extract gain curve for VLBI antennas from a dual frequency session file? This may be something for Mark or Des. I think Mark to.
So the easiest solution would be maybe to split the feeds, but I don't know whether the metadata will also be accordingly splitted or correctly splitted as well.
So the problem here is that the script, which is a temporary solution, doesn't really handle this. It assumes that you have a single DPFU, like in an NTAP file, for all your bands. A potential workaround could be to do the VLBA gains.key, but that probably doesn't handle SX either very well. The real solution is to wait until CASA 5.8 is released, which will have a proper solution where you don't have to use the script anymore. People that are interested in and want to run test work on a VLBA data set, I can give them a pre-release version that they can use to run import fits IDI and then go back to the official release to work on their data.
So this is something that we could also share on the wiki page for people if they want to have a quick access to this.
Maybe.
Okay, so afterwards, Carolina Casadio at 12:13 was asking about a way to calibrate the bandpass of the N14C3 using 3C345, which of course CASA has a task for that. But yeah, well, then it would be as easy as using 3C345 for the calibration and generate a bandpass table and then apply it on the fly for the forthcoming rounds of GainCal and of course included in ApplyCal as well. So it's just adding an extra table to the calibration using the generated with the bandpass task. So that was addressed. The question was addressed. Next question was by Perez Torres, asking for a way to trick CASA, okay, to use single pole channel antenna in dual pole observations, okay, because clean in the past was basically flagging the whole antenna. If you couldn't contrast, if you couldn't construct a bona fide Stokes eye from the visibilities, the antennas were flagged. So you were basically losing all single polarization antennas. There's an option though in the new T-Clean CASA, which allows you to construct what we call pseudo eye, okay, which means compute eye wherever possible, and if you find an antenna that only has one polarization channel, being it RCP or LCP, treat that signal as a Stokes eye, as if it were a Stokes eye. So you are neglecting a Stokes V, basically. You are neglecting any circular polarization from the source. This was present in other softwares, like for instance DiffMap, but was not, and Apes I think as well, right? It had this pseudo eye option, but not CASA. But now the T-Clean task has it, so there's no need of tricking anymore the data in order to not lose the antennas. But in any case, even if it wasn't here, you can use the MS tool or the TP tool, and in just 2-3 lines of Python, copy the RCP into the LCP in the visibility matrix and still use the antenna for the cleaning. So it was easy. And now it's even easier because you just select a Stokes pseudo eye and it takes care of it. So that question was also addressed. So there was another question by M. Husky at 12:16.
Ivan, sorry to interrupt. It's worth noting that this correlation-dependent flagging is only present in CASA 5.7. So if people are using the notebooks, and then I will discuss this also in my lecture later today, they are still using CASA 5.6. So they won't have the option to do the correlation-dependent flagging and would need to find another tool to do this. Okay, so in principle, using the TB tool or the MS tool, you could just copy the first polarization channel, which is RR, into the third one, which is LL, and then copy the flags as well from the zero channel to the third. That's definitely possible in 5.6. So. Okay. So then there was a problem with the DPFU of Westerbork. Okay, it was not being read correctly by the GC.py, but since the gain curve is flat, so in principle we wouldn't need to perform such a correction. So in principle that wouldn't be a problem in the end. Next question in a different thread. Let me look for this. What may be interesting is also a question for Mark. In some of the other channels, people are discussing the differences between Python 3 and Python 2 and how they handle the VLBI scripts. Is there anything that you can comment? Would the VLBI scripts work on the Python 3, or are there issues that people can expect there?
Most of them should work on both. The GC2.py script does only work with Python 2.
Okay, sorry to interrupt again, Ivan.
No problem. Of course.
Anything else that you would?
You should interrupt. Okay, there are other questions. For instance, residuals. Okay, systematic scene in the residuals of the N14C3 tutorial that can be attributed to some antenna errors, especially in the delay errors in session. Okay, that wouldn't be completely or fully corrected by the multiband fringe fit as noticed by Radcliffe, sorry. So that would mean that we would need to maybe tweak a little bit this delay correction, or just in GainCal try to IF dependent phase solutions in GainCal that would eventually correct for this. Other than that, I don't know if we can maybe fine tune the data weight and refine these delay corrections from the fringe fitting for session.
Can I jump in? Because
yes.
Yeah, this is from, well, I saw it because I built the Dara tutorials for it. And you need to do an IF separated fringe fit per scan to get the Shen delays in order. I don't know what was going on with the telescope, essentially, during this observation. So the multiband fringe fit doesn't entirely correct the phases.
So, yeah. So let's see. The next question that I see from a different thread is 1236 Ortiz Leon, who was finding outliers in the delay solution from fringe fitting, in the multiband delay solution from fringe fitting. So what was suggested was the use of plotcal, which allows for flagging. Okay, so it's based on matplotlib. It's a very old CASA task based on matplotlib, which has an interactive interface that allows you to flag solutions. Okay, gain solutions. But this task is not going to be supported anymore, as far as I know. So I think actually that in CASA 6 it doesn't exist anymore. Is it correct?
Yeah, that's right. The CASA 6 doesn't have it. That is why we advise people for the workshop to have CASA 5 installed. Yeah,
that will be a problem actually, because if there is no full support for plotting VLBI calibration tables in another task, that would be a problem in the future.
Yep. This has been extensively discussed a few weeks ago at the CASA Users Committee meeting, and there has been a plan that has been existed for quite some time already that this should all be moved into PlotMS. But the support for the type of calibration tables that is generated by fringe fitting is not very straightforward to implement in PlotMS, but they are very much aware of this. And I've pointed out to them that their claim that CASA 6 and CASA 5 are scientifically identical is for that reason not entirely true.
Okay, so that's something to take into account. Something to
yes, but a way to work around this issue, if you can't flag solutions in the solution table, would be to verify which telescope, which point in time is responsible for this, and then apply your data and flag the associated data instead.
Yes, well, there is a column in the calibration tables that can set a given solution as wrong.
Yep.
And then using the cal-only option would apply a dummy value. Or if you want to really rescue those data, you could actually substitute the gain solution by a simple interpolation from neighboring solutions.
Exactly.
Yeah, but that would be done by hand at the moment. So you would need to use the tools, the CASA tools, to do that by yourself, because I don't know of any task that would smooth solutions or remove outliers in CASA.
There is a smooth cal task in CASA.
But does it handle the VLBI tables?
I'm not sure. I've used it for system temperature tables, but I wasn't very happy with the way it handles the smoothing. It doesn't look like it's actually smoothing. It's more like introducing step functions in the file, which is also not something that you want in these cases. And it's actually on my list after the workshop to start looking at a way to do this in a better way.
Yeah, so in extremis you could do it using TB tools, the TB tool, for instance, and either flag the solution by setting the right value to the I think it's called the flag column, or just change the solution by an interpolation from the neighbors. That could be possible.
Indeed.
So then, yeah. Tell me, Ilse.
We are running up to the end of the question time. So if there is any, we can do one more if there is urgent ones that we have missed.
No, there was one about CVL. I think that is a matter of taste, whether to apply it at the beginning or at the end. It shouldn't harm much. And I didn't see any anyone which was critical, let's say. No, so nothing else that would be critical would be here. In any case, this is registered here, so in principle.
Yeah. Yes, it's not very easy to follow the threads. If you're used to Slack, this is definitely not what you would expect. But if you click on the little arrows on the side of the chat box for a person, you get the full thread, and you can scroll back and forth and read the whole discussion in a more sensible order than it's displayed.
Yeah.
I see one last question just popped in a few minutes ago from Isla Ortiz Leon. Plotting. And I think this was remarked before as well. If you plot the data from the tutorial, you do not get quite the same plot that Des has in his tutorial. And this is on my to-do list actually for this workshop to make sure that this is fixed, because it has to do with the flagging. Some of the data that has been flagged in the images that are in the EVN Jive tutorial are not being flagged in the processing steps that are in that tutorial. So it's not a really big deal, but it's good to see that several people are now showing the same plot. So actually the tutorial steps are still consistent. And now it's just a matter of figuring out which was the flagging command that we missed in the tutorial and add it back.
Mm-hmm.
I'm checking if there's any other questions that we need to address. If not, then we are going to close off this data processing session.
Well, there was actually but it has been addressed already about what happens when you run apply cal with the corrected column. But I think in the answers in the thread, it's very well explained. So,
yeah. That's right. So, but that's also a good thing to mention, that the corrected column is never safe when you do data processing, but your data column is never touched. And there is an option, a task called clear cal in CASA. So if you know that your data column is still okay, but your corrected data column somehow is really weird, you can run clear cal and it will overwrite the corrected data column and also your model data column. So be aware of this. And you can start with a relatively clean measurement set.
Yeah, the problem is that if you want to compare several different calibrations and you want to compare one-to-one, a good option actually would be to split the corrected column into different measurement sets, so you can compare. Because you only have one calibration version every time. You have to run apply cal every time, and you lose the previous calibration. So if you want to keep it, you have to split.
Yeah, that's right. Okay. Well, thanks everybody. There's been lots of very useful discussion. I hope that at least the data processing itself is also going well. It's tricky for us to gauge exactly what you are all doing. I wish we could have a little sneak peek and see which projects people are working on. So maybe we'll think up a way to have a little bit more interaction later in the week. But for now, this is today for this is the way we'll handle the data processing sessions. A logistic request came up from some of the Chinese participants. They asked if we could have a Zoom room open for them in very early morning UT hours. And this is totally possible. And I can also suggest for people on the other side of the globe in the Americas, if you need access to a Zoom room for the plenary session or to interact with for your people who are in your time zone, we can set that up. These would be plenary sessions, so everybody can join and everybody can leave at the time that they feel fit. For the webinar sessions, this is trickier because you need a host. So we'd always need to be either myself or Olga to be awake to let you in. Which is okay for early morning hours and evenings, but midnight is sort of pushing it for me. But if you want a Zoom room, the general plenary sessions we can set up for you. So just let me know if that's something that would be useful to you. So for now, here it's lunchtime. For others, it may be dinner or breakfast time. We have a break of 1 hour, if I'm correct. Yes, and we start again at 1:30 UT. After lunch, dinner, breakfast, whatever feels okay to you. So we'll see you there.
Okay, see you later.
Bye-bye.
Bye.